All right. Anyone here able to hear me? Hello, hello. Here we are. Hello, everyone. Thank you very much for joining. I appreciate it. I'm just squaring away our last couple details here, and then I'll get this show on the road. All right, and now hopefully all of you are able to hear some smooth jazz, perhaps. Peter is telling me the music is too loud. Awesome. All right, so thank you very much, everyone. I'm going to wait a couple minutes for people to trickle in, and hopefully the music is pleasant as we work our way there. Awesome. All right. So I'm going to give this another, I want to say, minute before we start, but feel free to say hello in the chat, introduce yourself. I'm certainly happy to say hello as well. All right. Well, might as well at least start getting some of the basics out of the way so we can get this show on the road. There's the chat. From Brazil. Amazing. Pleasure to meet you. Thank you very much for coming, Juan. Thank you, Alberto. Thank you, Jura. Good to meet all of you. All right, so I may have said this earlier, but I'll just start with the basics. My name is David Awad. I am joined here by Peter Lee. Two of us are developer evangelists here at R3 working on Corda. And so today we're going to give you a pretty intuitive basics developer boot camp. We're going to give you an intuitive technical understanding of the core abstractions you will need to build applications on Corda to use blockchain system. It should be pretty interesting, especially if you've never worked with blockchains before. I think they're pretty reasonable paradigms, so you'll probably have a good time with them. So all that being said, I think we can just get started. A couple logistical notes. So I am not going to be able to see the chat during most of this, but my colleague, like I said, Peter, is with us in the chat. So if you have questions at any time, drop those questions in the chat. Peter will get to them. And if it's something important enough, he might stop me or call my name or something like that so that everyone can hear the answers to them. But yeah, that's about it. So again, feel free to post anything you need. Happy to go back and answer any questions. But this should all be pretty easy for most of you, especially if you've written a good chunk of code in the past. None of this will be too surprising. So as far as a loose agenda for today, we're going to go through a couple of things, what CorDapps are, and then we'll talk about those three kind of critical abstractions, states, contracts, and flows. I'm actually going to build an app live with you. That sounds more impressive than it is. Certainly it's an app I've written before, but we're going to do a basic token CorDapp and try to just demonstrate how this looks in practice after we go over those abstractions. Then we're going to take some questions. Of course, we'll be taking questions throughout, but we'll have kind of a break at the end. We'll stop the recording and just take whatever questions people have. So if that sounds good to everyone, we can just get started. I should actually have a seventh item here. We do have a survey that we try to share at the end of these. So if you have notes or feedback or things we can improve on, please do feel free to Okay. So As always, the online resources available to you are plenty. Corda is open source. You can find us on YouTube. You can email us. You can find our free training and documentation sites online at these links here. And of course, you can reach Peter and myself over email, our public Slack channel, and on Twitter with all of the various hashtags. So please do feel free to use them or take a look at the source code or read up. And all of our documentation resources are also open source. So if you want to make PRs or anything against those, you're more than welcome to do so, and we appreciate it. So those are all the resources you're going to want to be aware of, at least for today. So the first thing I want to talk to you guys about is what actually is a CorDapp, right? So let me actually stop the music. It's kind of distracting me now too. So what actually is a CorDapp is the first thing. We say this term CorDapp, it really means Corda decentralized application, which basically means it's an app that runs on a distributed system. It's also sometimes referred to as smart contracts. And what that really means is that these are binary jars that are stored inside of Corda nodes, and each node can carry multiple of them, right? So CorDapps are written in JVM compatible languages. We often say Java, but it can also be Kotlin. And what we're going to do is once we have compiled our CorDapps that define what our smart decentralized apps are going to do, then we can take those apps, publish them. And by publish, I really just mean copy the compiled jar file. You're literally just going to copy that jar file onto the nodes that are running your particular app. So for example, if A, B, and C are three different people, and A wants the Hello World CorDapp, A can transact with B and C since they both have it, but A can't participate in transactions that are defined in the whistleblowing CorDapp because the whistleblowing CorDapp doesn't exist inside of A's node. Simple as that. If you wanted to install that CorDapp, you can just copy it onto A's node, restart Corda or what have you, and you're good. It's as simple as that. And so you can very easily write CorDapps with other people or share your code ahead of time or what have you, write and agree on the code you're going to use to manage a particular agreement you have, and then distribute it among everyone's Corda nodes, and then it can be managed by the blockchain. So what are the components of a CorDapp? There's three main components that you want to be aware of: states, contracts, and flows. So states are exactly what they sound like, or sort of what they sound like. They're objects in Corda, meaning these are JVM compatible objects. These are Java classes that implement Corda abstractions that are given to you. So you will write Java or Kotlin or whatever, JVM classes that implement these Corda abstractions, and anything you can represent in a JVM class can be represented as a state. So for example, this could be something like a car, where a car has a mileage, a license plate, etc. All of those things are possible to do in a state. You'll then define a contract that is uniquely associated with a state, and that contract defines what those objects can do. So for example, in the case of cars are manufactured, they are issued onto the blockchain, maybe, they are sold, maybe their mileage is updated, cars are repaired. It's just a question of how granular you want to represent your states and what kinds of operations you want to be able to represent. Things like issuing a car onto the blockchain for the first time, or modifying your car after it already exists because the state has changed somehow. These things are all outlined in contracts. So your last question is probably, now that I've defined what the objects are and what I can do with them, what are flows? And so flows are exactly the mechanism through which you update the blockchain, right? You create objects and then you use flows to update those objects and modify them. And contracts define what the modifications are that you can do. If all of that makes sense, then our live coding will make sense. We're going to write about three different files to build a token CorDapp, meaning an app that simply represents a token, like a coin or something like that. And this token CorDapp is going to be very simple. All it will have is an amount, and it'll have an issuer and an owner. So it's almost like an IOU or something like that. Let's say you came to my arcade, I want to issue you a token I could use Corda to do that. Maybe you scan a QR code with your mobile phone, and I run a flow issuing a token from my node to yours, or something like that. There's all kinds of ways to do it. So to start with, of course, we need to look at states. And so what the heck is that? That is tremendously upsetting that that came back. Huh. Okay, well, let me see if I can get rid of that. I don't know what the heck that is. I'm going to just accept that that is not going to go away. All right. States are not pencils. States are any object. They get created, they get updated, and then they are consumed. And like I said earlier, they're objects on the blockchain. And so as part of our live coding, what I'd like you to do is I'm going to grab this Bootcamp CorDapp repository, the V4 branch. And if you would like to follow along with us, I'm going to post this link in the chat. So you can grab that and use it to code along with us. So that link is going to take you to the Bootcamp CorDapp, and you will see a couple of different files. And we're going to clone this together so that you can all see where I'm going with this. Let me create a new folder. So I'm going to clone the Bootcamp CorDapp, and I'm just going to call it Bootcamp May 27, 2021. Cool. So we're just going to clone our Bootcamp. Awesome. All right. So inside of there, you should see the V4 branch. We have a bunch of files. We're not going to be super worried about operating on it with Vim or any of that. That tends to be a really painful thing to do. If you look in the docs, you'll see that the recommendation for how to edit CorDapps is actually with IntelliJ. So I'm going to pull that up. And while we wait for that to get started, I'm just going to tell you a little bit more about what we're going to do. So a state is an object on the blockchain. I told you it's represented by a JVM class, and we described a pretty simple token interface that we're going to use. And so that is going to be called the token state. So our token state is going to live in a file called tokenstate.java. Very surprising. And what the properties will be are going to be simple things. We're going to have an issuer. Maybe we'll have an owner who currently owns this token, and then we'll have an integer for the amount, right? How many tokens do I have? How many have I issued to you, the current owner, etc. So if that makes sense, then we can go and clone this CorDapp and get started writing our first one. So all of you hopefully have this link. So grab this link, clone it onto wherever you like, in my case on the desktop, and just open that up in IntelliJ. Now, the way you're going to want to do that is, let me get rid of all this. You're going to want to hit the open, not import, but open. And IntelliJ will ask you where to grab your CorDapp, or rather where to grab your project that you're going to be working on. In this case, we're going to select the actual directory itself. I called it Bootcamp May 27, 2021. So we're going to hit open there. And there's a couple things we're going to want to make sure of. So while we wait for this, you'll see we get this little thing in the bottom. IntelliJ found a Gradle build script, which is correct. So I'm going to hit import Gradle project. The specific Gradle build script it's talking about is this one. There is a root build.gradle right in the root directory. Now, before I go too far here looking at code, I want to make sure everyone can see this. So does this look good, or do people need it to be a little bit bigger? I'm going to actually go to the chat, and if you guys could just tell me how it looks. The
font is fine.
Awesome. Thank you. Great. So if the font looks good, we're going to want to make sure of a couple of critical things before we get started writing any code. First, you saw that I clicked that import on the bottom right there. And what that's going to do is it's going to make sure that this Gradle script has all of the dependencies and things that it needs. A quick logistical note, we're actually updating this in the next couple of days. This particular CorDapp, the Bootcamp, is set to 4.3 as far as versions. The latest version of Corda is 4.8, but nothing that we're going to teach you is out of date here. These critical core abstractions have not changed at all. And the way that you would write them essentially has not changed since 4.3. So just bear in mind, if you saw that and you're wondering what's going on there, everything that we're going to be teaching you is exactly up to date as far as how we deal with states, contracts, and flows. But if there's any version specific stuff you want to ask, by all means, feel free to. So 2 places. If you look at the docs page for getting set up, let me see if I can find it. Setting up. Yes, there we are. Getting set up for CorDapps development is pretty intuitive. The big note is just that we currently support JDK 8. So you're going to want to make sure you have that installed. And I'm going to show you how to double check that as far as IntelliJ. And this has links to other things you might need if you don't have Git or IntelliJ or the right version, etc. This is all outlined on this docs page. So you will be good if you can check that. There's a couple places we're going to go. I'm going to hit Command, comma, the shortcut to get me to project settings. Sorry, I think it's Command semicolon. Yep. So you're going to want to make sure as far as your project version, just make sure you're set to 1.8.0_242. We won't be able to help you with your specific SDK stuff here, but just try to make sure you've got that set up correctly. And you'll have a similar thing here inside of project structure. I believe it is one of these, yes. Inside of if you click this Gradle icon on the right here, it'll expand this menu. Click the wrench and you'll get to see Gradle JVM, and just make sure you've got 1.8 here as well. I've seen people get burned by this. I myself have been burned by it many times. So just keep those little things in mind. And again, you can get to that menu just by clicking this button right there. So I'm going to slide that over to the right. We don't need that right now. Most of what we're going to be worried about within here, I'll spend a little bit of time looking over the build.gradle now, but it'll probably be more useful later. Where we're going to be looking open source, main, Java, you'll see bootcamp and examples. And so maybe we can start with this example art state and open up token state as well so we can write one. Now, my quick notes on build.gradle. Here is where most of the things that your CorDapp needs to know to run, quote unquote, is going to be defined. Things like versions of packages is all defined here. The Maven repositories where you're going to get most of these things, the plugins, dependencies, all of that is defined here. You don't need to worry about most of that. What I do want you to be worried about, or to be rather aware of, is here. Now, we conventionally call this task deploy nodes, and this is the task that compiles your whole project. Here we've defined a couple of basic nodes. We have a notary, we have party A, party B, and party C. These are the nodes representing the 3 individuals whose CorDapps, whose Corda nodes exist on this network. These 3 individuals have been defined explicitly. You know that because it says right here, peer-to-peer port 10,003. We define the address of the node. We define the port that the node will take its traffic on. And we do that for all 3 of them. We, of course, define their names and locations. For example, this one is in Lagos, Nigeria. This one's in New York. This one's in London, etc. These are X500 qualified names, just for those of you who are so inclined. So just be aware this is where the majority of the concepts as far as the network's operation are being applied. Now, this config file gets processed depending on what kind of Corda network you're creating to lay out all of your network resources when you might go to actually deploy this thing. So forgive me if that's maybe a little bit more detail than we should have had at the start of this thing. Let's now look at an example state. So as far as the PowerPoint, token state.java is just an object. It contains an issuer, an owner, and an amount. Art state is a good example because it's got a similar story. We'll define things like the artist, the title, appraisers, owners, but we have a constructor just like anything else. So if you get stuck as we start writing, just refer to the art state. It has a whole lot of the things we're going to use. And it makes it pretty clear as far as what you'll want to refer to if you get stuck or you get lost along the way. So our token state. Our token state has, like we said, an issuer, an owner, and amount. So before we can start writing our token state, we actually need to do one quick thing. I'm going to add a logistical thing. You'll see we've got it commented out here. Every state is associated with a contract. In this case, the token contract, because the state identifies the object. The contract is what you can do with it. So if we open the contract, you'll see that this file exists, but we haven't filled that in yet either. We're going to look at that later, but the first line here that's commented out is that it belongs to that contract. So just keep that in mind. Now that we've done that, let's go and actually start defining this thing. So the first thing that I described to you is actually that the class token state implements a Corda abstraction, right? It implements contract state. Awesome. Now that it's implementing the correct Corda abstraction, we can start giving it some private member variables. So I'm going to start with a party, and a party is a Corda abstraction. We're going to give it two of these parties. We're going to give it an owner and an issuer. Then we're going to give it an amount. Then we're going to give it a list. This is a list of type abstract party. And this is going to seem a little bit confusing. It's called participants. Oh man, I cannot type today. What's it complaining about here? Right, of course, it's going to say all of these haven't been initialized. That's not surprising. We don't have to worry about that yet. Now this abstract party list of participants actually defines, it's a Corda abstraction that defines who are the participants of transactions in which this state is a part of. And that will come into play a little bit more later. But first, I'm going to define the constructor for this. So we're going to say public token state. I'm going to have a party issuer, party owner, and of course, an int amount. So it's not going to surprise you that the next thing we're going to do is I'm going to say this dot issuer equals issuer, this dot owner equals owner, and you'll see these errors start to go away. This dot amount equals amount, right? We're just setting the things we get in the constructor. Then we're going to say this dot participants equals, and we're going to set this to a new array list, because right now the participants are just going to be the issuer and the owner. These are the only entities, these are the only individuals that will participate in this transaction. So we just have to add them. So we're going to go participants.add, owner, participants.add, issuer. Simple enough. So now we have our constructor. Some of those errors have gone away too, which is nice. But now we just need to give ourselves some getters and setters. If I'm remembering the command correctly, I believe we can generate some code, Command N. So we can generate some getters or setters. In our case, we're just going to generate a couple of getters, and you can actually go and just highlight all of these. I'm going to define getters for all of them just to save a little bit of time and typing here. So we have getters for the issuer, the owner, and the amount. And of course, these are of types int, party, party, and they're all public. All of these methods are public with the exception of the private member variables. So we're using a little bit of proper design and proper object orientation here. This last method is going to be interesting to us, at least a little bit. We're overriding a method given to us from that contract state. Corda contract states have to define the participants within their transactions in order for Corda's state updates to work properly. It's not super surprising given that it's a point-to-point network. If you saw our last boot camp, you hopefully remember that all transactions on all transactions on Corda networks are point-to-point. And so the states are only shared between the individuals who are actually a part of the transaction. If you keep that fact in mind, this will not be a very surprising thing. And so the participants in this case have to be given by the state, which is why we defined them here and added them to the participants array list. And so that comes out into a public list. And we specify that it is not null, and that add override directive just tells Java, hey, we're overriding the method from the contract state interface. Awesome. Any questions on this before I keep going? Let me check the chat and see. Awesome. Okay. Looks like Peter's got me covered as far as questions are concerned, so I'll keep going. Now that we've got our state set up, the thing I want you to think about next, of course, is the contract associated with it. So let's go back to the slides for a hot second here. Assuming that animation actually, oh, that was actually quite, nice, love it. All right, so contracts. So a contract defines, like I said earlier, what can you do with your objects? In this case, contracts define the actual updates you can apply to different states. There's only one contract for each state. Ideally, that is. So a ledger update is done through transactions in flows. Contracts will verify the validity of the proposed updates. So what contracts or what transactions will generally do is you'll have a state that is consumed as input. So for example, let's say I am selling you my car. Well, now you're going to be the new owner of the car. We know the desired output state, right? The output is going to be that maybe Peter is the owner of the car, right? So what's going to happen? The owner, in this case, of our state might change. The owner is going to change to Peter or something like that. So the input is going to be with me set as the owner because I'm currently the owner of the car. But once I sell it, the desired output state is Peter being the owner of the car. And so what happens is every input or every token, every state on the blockchain is consumed in a transaction that encapsulates the input and the output. And only if the contract verification succeeds is this update considered valid and able to continue. A good thing to Google after this would be how Corda models transactions. The model is called unspent transaction output, the unspent transaction output model. There's more than one way to model transactions on a blockchain, and consensus and all of those things. It's a little outside the scope of what we're talking about here, but it'd be a good Google to look at the unspent transaction output model on Wikipedia after this. So transactions consume this input and output. These contract rules have to be followed. Only when the rules are all valid, this is an and relationship, only when all of those rules are followed is a ledger update considered complete. So what are some examples of contract rules? We talked a little bit about this earlier. Let's say, for example, a car's mileage cannot be negative because that's not possible. In New Jersey, where I'm from, license plates all have 6 characters, for example. Those of you who are into VIN numbers probably know that VIN numbers identify specifically the manufacturer, the make, and the model, and the number specifically of that particular make and model of car that was produced in that factory or wherever. All of these things must be specified by the VIN number. And so a non-compliant VIN number might be something that would also fail a contract verification. And so what happens if they do fail? Well, the update is rejected. That's not probably very surprising. The updates are crucial if one of them is not followed. That's why you are agreeing to a smart contract in the first place, because you trust the ledger to ensure that your contract terms will be enforced. So if, of course, they are not, it will not work. So let's actually go and define what one of these contracts might look like. The slides actually reminded me of this, of one other aspect of this that we should talk about, at least just for a moment. In the case of our token state, we're going to implement an issuance transaction here, right? We're not going to be updating. We're just going to be issuing a new state, right? Our token state might have a couple of simple things, right? Issuer, owner, amount, whatever. But what we're going to do is, what I'm describing earlier here is an update transaction that consumes an input. But of course, in order for the car to get onto the blockchain, it has to be issued onto it, right? The car has to exist first before you can start moving it around. That is what issuance transactions are all about. So issuance transactions do not consume an input. And usually the required signer is just the issuer. So that's an important caveat to keep in mind. But it's not a particularly complex thing, just something to be aware of. In our case, we're just going to be doing an issuance transaction. And so what might an issuance look like in our contract? Well, an issuance is a particular type of thing you can do, a command, you might call it. In Corda, we call these things you can do commands. And so we might define a contract command called issue. And the issue command is going to allow us to specify what happens when we issue a token. And so when we issue a token, what's going to be the case? Well, issuing a token probably has no inputs. There's maybe one output, right? Just right here, no inputs, one output, the token state. The output must be an actual token state, right? I can't launder a car through the token state contract. That's not going to work. The issuer should be a required signer, right? If I'm going to claim that I have something, I should probably be the node that's going to do that. And let's say I'm issuing a token to you. If I'm going to give you a token, you probably should also know about it, meaning your Corda node is also going to be a required signer. And what else do we know about amounts? Amounts are usually positive in the case of a token. You can't have a negative amount of quarters as a good example of that. Awesome. So let's go back to IntelliJ, and we're going to start implementing some of this. You're going to want to look in the same folder, source main Java bootcamp, excuse me, token contract. Token contract is our next stop on this wonderful tour. Now, the first thing, and I classically always forget to do this when I run this particular bootcamp, the first thing you're going to want to do is actually go up here. Like we talked about earlier with token state, we are going to implement the Corda abstraction. Token state implements contract state. If you do not add this, you'll get into all kinds of weird issues. So token contract implements contract, which is yet another Corda abstraction. Now you may get this little red line. There is a keyboard shortcut you can use if you are on Mac. I do not know the shortcut on Linux or Windows, unfortunately, but just hit Alt-Enter, and it will give you the option to automatically import that tool. Let me leave my imports open here so that you guys can just copy that if you like. So the first thing we define is an ID. This is basically a string. It's probably going to match, generally speaking, it's going to match the package name of the contract. You're going to want to make sure that this is here and keep it unique. In this case, I'm going to leave it as bootcamp.tokenContract. And you'll see right over here, the first thing that exists is this verify method. I'm going to add a quick decorator to it. I'm going to give it an override directive because now we're overriding, or rather implementing, the contract interface. So, whoops, there we go. Inside of our verify method, the first thing we're going to do is we're going to use this transaction and we're going to get some information out of it. So let's start with the command with, actually, before we go there, I should highlight, we define this interface down here. Before I talk about the verify method, I said earlier that commands are the names, almost like method names, but don't get confused. These just define the names of what we can do. So class issue is just a name. This is purely a semantic name. I could have another class called David that implements commands. This is just a semantic name. And there's more you can do with them, but for the sake of convenience here, they are just semantic separators. You can have things like command and issue and update. And what we're going to do is inside the verify method, we're actually going to specify what kind, based on what kind of command it is, what kind of verification will we do? Because this one contract outlines all of the logic for the token state, right? So there's going to be a lot of different kinds of verification depending on what kinds of things we're going to do. So I'm going to create a command with parties array of type token contract dot commands. And I'm going to call it command. And what this is going to do is it's just going to be it's going to be a small list that contains, sorry, I shouldn't say list. It's going to contain the actual commands that this particular transaction contains. In this case, we're going to use require single command, and we're going to get the commands from the transaction. Note again that the transaction is passed to us in the smart contract. So the transaction, whenever a state is involved in a transaction, the transaction is given to us at the contract level so that we can run with it. So I'm going to go in there. I'm going to specify tx.getCommands. Sorry, that should have been get commands. And I'm going to specify I'm getting commands of type token contract dot commands dot class. And this token contract dot commands dot class is this that we defined earlier. So now we've got our command. We're calling a specific method to get a single command of a specific type out of here. And so if this command exists, then we can go and do things with it. So I'm going to say contract state. Whoops. I need to make that a list. What am I doing? So I'm going to create a list of type contract state called inputs to the transaction. And I'm going to say tx.getInputStates. I'm going to do the same thing. I'm going to get a list of type contract state, and I'm going to call this one outputs. And of course, I'm going to change this to tx.getOutputStates. And now this is another one of those imports you're going to want to get. That will be right there. Net Corda contract state. Now we have the inputs and outputs to our transaction. So what we're going to do is we're going to make sure that for this particular verification, since we're only worried about issue, I wrote update here just as a matter of convenience, but we're going to worry about issue. So I'm going to say if command.getValue instance of token contract dot commands dot issue or update, just issue, right? So if we are looking at an issue command, the command for this transaction is the one we expect, then in this case, we're validating an issue command. Feel free to tell me if I am going too slowly. I understand if some of you might think I'm being a little bit repetitive here. I can wholly appreciate that. I'm going to define a quick anonymous function inside here. And this require that is going to give us our ability to require a series of validations. And this is going to be everything. So transaction must have no input states. This is going to be our first condition. We define, just like with unit tests, we're going to define the actual string associated. Then we're going to actually put the conditional, in this case, transaction has no input states. So we're going to say inputs dot is empty. Whoops, there we go. So this is probably not super surprising. Now we're going to do a similar thing with output states. Transaction must have one output state, right? Now, if we're going to have one output state, then what are we going to do here? We're probably going to use outputs. Outputs.size, and I'm going to go equals 1. Awesome. So now let's keep going. We're going to add some other conditions that look interesting. The output must be a token state. And again, I'm not making these up. These are what we were talking about here. Output must be a token state, issuer required signer, etc. All right. Output must be a token state. Then I'm going to go outputs.get 0 instance of token state. Now, just for the sake of time, I'm going to just bang out the rest of these. They're conditions based on what we already talked about here. I'm going to just do issuer required signer, owner required signer, etc. I'm just wondering why output is red here. Oh. Oh. What is the, oh, I forgot something. This is what I get for writing code without thinking. I'm going to create a token state output for convenience here. I'm going to cast it to a type of token state. What I'm doing here is I'm just creating a reference to the actual token state included in the transaction. Because now I can go and grab that and use output.getIssuer.getOwningKey. What this basically says is in the required signers, the issuer's owning key should be in there. So if that makes sense, I'm going to do the same thing for the output, or sorry, for the owner. The owner is also a required signer. One thing to note, by the way, this get issuer and get owner, these are the methods on the actual output state. This is a token state, the one that we defined earlier. So I'm calling these getter methods. Note here how get amount is still gray because it's never used, but get owner and issuer are now being used. So that's where this is coming from to refer to the specific get owning key method, which is called on the party abstraction. And last thing, required using amount must be positive, nothing surprising there. Here, I'm just gonna forget all of that. I'm gonna say output dot get amount greater than 0. Amazing. Now, there is a little bit more we can do here. We can add an else to the if. We checked first if it's an issue command. We can, if it's invalid, we can throw new illegal argument exception bad command. We can totally do that. That's all fine. Great. Okay. So we've now written out our contract. Hopefully all of this makes sense. We got just enough time for taking any questions on this. And if you are unsure about any of the code we went through, or you're looking for examples, check out the art contract. It's a little bit more verbose of an example, but it's a good place to start if you're not sure about how some of these things are happening. So I'll leave that open. Any questions in the chat? Can you wrap your code so we can see what's cut off? Was confused about the part that was cut off. Sorry about that, Brian. Yeah, so what's happening here, actually, here's an even better example than me explaining what this is. I do not know how to wrap my code in this editor, unfortunately. I've not done that, but what I can do is I'm actually gonna give away a little secret here. The solutions to this are actually outlined inside of the Bootcamp CorDapps, so you can see the specific code that was in here. I'm not writing exactly the same code, but it's essentially the same code. I've just done this a bunch of times. So that might be a good place, Brian, if you're looking for the specific thing that was happening there. If you want to ask questions about the actual abstractions, I can go over that too if you like. Feel free to just post if you want. So I'm going to assume that will work, but again, just post if you have questions. I'm happy to go over that. Thank you for the question. All right. So what are flows? Now, this is the last abstraction on our tour. Now, right at the beginning, we said states are the object. Contracts define what you can do with the object. And flows are the actual doing of things. Flows are how you actually trigger state updates or updates to the ledger on the blockchain. Now, this diagram makes it seem a lot more complicated than it is. A flow is two pieces of code, an initiator and a responder. This makes sense because these nodes all exist. One is going to talk to another. So of course, if I'm node A and I'm going to initiate a blockchain update, of course, I'm going to have to talk to you, node B. Of course, they're going to have to talk to each other. So of course, B must have a responder. And so the role of who is initiating and who is responding simply changes depending on whose flow is running what. And of course, a little bit on the CorDapp itself. So let's talk about this a little bit. What happens in the course of a transaction? Well, let's imagine I'm node A and maybe the B is node B. We'll just call them B. Now, A is going to start, they're going to initiate this update to the ledger. They're going to initiate, let's say, an issuance on the blockchain. And so if I'm running an issuance, what I'm going to do is I'm going to propose the update, meaning I'm going to run the flow locally on my node. Assuming it's valid, or assuming the flow accepts the inputs or what have you, I'm going to propose the transaction, form it inside of the flow, and we'll talk about what that means. I'm going to check the update locally with my own smart contract code. Then I'm going to sign it. Once I've signed the update, meaning once my own smart contract verifications have been run on my proposed update to the blockchain. And again, the CorDapp is shared between all of us. So we all know exactly what code is being run. So assuming it is valid according to my CorDapp, my contract code, then I send it out to B. B responds to the flow. B gets this proposed update. B runs the smart contract verification as well. B then checks the update, right? Runs all the same checks, 6-character license plates, qualified VIN number, non-negative mileage, etc. If it's valid, B signs it. B gives this information back to A. A then takes this signed transaction to the notary, which then validates the signatures of the parties, ensures that the ensures this state is not being double spent, etc. The notary signs the update. You can apply a whole bunch of configurable verifications to the notary, by the way. I'm just hand waving over it a little bit here to save time. The notary is going to sign that update. The notary then goes back to A and says, hey, I want you to record this update. A goes to B, B records the update. Then we're done. That is all that happens. So again, it is A running, A validating the update, B validating the update, the notary giving it the thumbs up, and then everyone records it and we're done. This can happen as a subset within a larger Corda network. This is important to keep in mind. So, whoops. Okay, so let's go back and actually write out the code for this. I'm going to try to do it a little bit quickly since we don't have too much time, and I want to make sure there's time for questions. We talked about an initiator and a responder. And so you've probably realized these are in the same folder: source main Java bootcamp, flow initiator, flow responder. Flow responder is basically done. You don't have to do anything with the responder. The responder is going to take the flow it is given. And if you would like, you can add additional transaction checks and things like that. But usually, at least most CorDapps don't tend to do too much at the responder level or at the flow level. Depends on how you want to do it, but most of the time, the majority of the work happens within the contract as far as making for valid CorDapps. Now let's talk about what actually happens. Now, when we're running a flow, you're literally going to the command line, or maybe you're making an HTTP request or an RPC call. You're supplying this information, the owner and the amount, for example, to a node, and that node's going to issue the token. In this case, let's go look. The first thing that happens when our transaction is called, the constructor just takes an owner and an amount. A progress tracker is created. This is just for demonstrating on the command line, if you're using the Corda shell, what is happening. So we don't have to worry too much about the progress tracker, but it is required to have for monitoring and other things. Call. The call method, once again, being overridden, suspendable, is another nice one, but we can talk about that later. The call method. We're going to specify the notary for this transaction. In this case, we go to the Corda Service Hub. This is just a tool for us to get, references to resources on the Corda network. In this case, we get the network map. We get the notary identities. And then we call, what the heck was that? All right. We get a reference to the notary identities. We get the first one. Now we have the issuer. That's going to be us. This node that we run this flow on is going to issue our identity. So now we're going to create a token state that actually represents what it is we wish to create. We're going to create the desired output state, the actual literal update we want to make. So the first thing, of course, is now our token state is set to token state equal null. But that's not really what we want. We want a new token state And what are we going to pass here? The issuer, right? That's us. The owner, that was passed to us. And the amount, right? The issuer is us. We got that reference here. The owner was specified when the flow was ran. That came from the outside over RPC or HTTP, whatever. Amount, same thing. Now we have that. What do we do next? We're going to specify the actual command that we're going to use. And we're going to put that command into a transaction. So a transaction builder is how we're going to do that. So we're going to call the transaction builder constructor. We're going to pass a reference to the notary. This is the notary for the transaction. But of course, now we have to actually build, quote unquote, the transaction. That sounds too cheeky. So the first thing we're going to do, let's create a command. I'm going to call it command data. This is just an abstraction for, this is just an abstraction for maintaining that what we're going to do is we're going to run the command token contract.commands.issue. Right, this is an issuance transaction. So we should be all good there. I should not have called or used those parentheses. So that is all we need. Token, that's where they should have been. Token contract.commands.issue, great. Now we're going to add this command to the transaction builder. Transaction builder.add command, command data, issuers owning key, and we're going to add the owner's owning key. There we go. So now we've specified who are the participants of this transaction. We add them to the command. We've specified what command is happening. So the transaction builder knows what command this is. Great. Now we're going to specify what's our desired output state. So we're going to go back to the transaction builder, .add output state, and then we're going to specify none other than token state, the one we created here. Token state being the variable name, not the class name. We called the token state, but it didn't have to be called that. So one other thing I should have also said, we're going to specify the token contract ID for this method call. You don't have to, but it's better to do it with it. And now during our flow, now our Corda node knows when this flow is run, now we're going to verify this transaction, right? Now we've defined all the parameters. Now we're going to run the verify method to actually verify this transaction. And for that, we just pass a reference to get service hub, and the verify method will get all of the things that it needs within the Corda service hub to go and actually verify the transaction, call the contract verification, all of that. We don't have to do that here. Now our flow session. A flow session is a little bit more tricky to get into here, especially since I guess I've been too long-winded today and have spent a bit more time than I wanted to, but let's just move along here. So we're going to initiate our flow. We're going to pass the owner here. Why are we passing the owner? Because we're initiating the flow from this node, which is the issuer, to the other node, the owner. And so that's why we're initiating from us to them. And of course, we're going to sign the transaction, making it immutable. Then we have the fully signed transaction, which is when they have signed. So we're going to run a subflow called a collect signatures flow, called the collect signatures flow. When we've run this subflow, the collect signatures subflow will go to the other node, will go to the owner, in this case B. This is how we go to B and get their signature, get them to run the verification, etc. And then once we are done, once we have the fully signed transaction, which is to say the transaction that we have signed and that they have signed, now we can run the finality flow, which you can read more about in the docs, where we get the transaction notarized, meaning going to the notary, waiting for the notary to respond back to us, and then we sign it and update B, or rather we update all of the parties involved in the transaction. Everyone has signed it, now we're all good. And that is the end. Once this has completed successfully, the state has been updated and we are all done. So that is pretty much everything you need to know on the basics here. Now I can run this and demonstrate to you guys that it works with unit tests or something like that. You can find those things, by the way, inside of here. Source, test, bootcamp, and we can go and look at some of these if you are curious. Assuming you believe me that the code works, which I suppose you don't have to, you can try taking a look at some of these unit tests that are defined here and see how they pop out for you. It might be worth doing. There's also some tests, demonstrations for art, etc. But I want to just make sure that we got all of that out. Hopefully, Peter, you can drop that survey link. Amazing. So if anyone has questions on anything we talked about here, that I would love to hear that, because I know this is a lot of information, so it can be a little bit tricky to grasp. So anyone have any questions? Awesome. I did promise you I would stop recording, so I will go and do that now. But yeah, since I'm about to take questions, I just want to thank everyone for taking the time. You are more than welcome to email us. Again, my name is David and it's Peter in the chat. I believe, yes, Stephen, there will be a link to this recording. I believe it will be emailed to you, but feel free to follow up with us after if you don't get anything. You can find Peter and myself and others on slack.com, or sorry, slack.corda.net. I also recommend taking a look at Conclave if you're interested in this kind of confidential computing. It can be quite fascinating to learn about. And so Conclave is our other product that we evangelize that allows you to create secure enclaves on hosts or host operating systems that you do not trust, which is pretty fascinating. So I will stop the recording there and take some questions.